In 1847, Hermann von Helmholtz published a theorem showing that the work done to an object when there is just one force acting on it equals the change in that object's kinetic energy. Based on this result, what would be the appropriate unit for work? So, what is being described there when we say work is equal to a change in kinetic energy? You could summarize that in a simple formula. W is equal to delta K, or you could even say K minus K naught, in other words, final kinetic energy minus initial kinetic energy. And it turns out another part of that we'll probably look at in some future examples is that the general formula for kinetic energy is 1/2 mv squared. And so that means you could actually rewrite this last part as the difference between the final kinetic energy in terms of 1/2 mv squared minus 1/2 mv naught squared. In other words, if the object started with some initial speed v naught, wound up at some final speed v, this would be the full formula. So let's get into just a little bit some more of the details of what Helmholtz actually published. But the question that we're looking at here is actually far simpler than all of that. It just says what would be the appropriate unit for work. Well, the thing to recognize is when I say, when I'm talking about kinetic energy here, right, this is energy. What is the unit of energy? It is the joule. This formula, though, says work is equal to a change in kinetic energy. Well, a change in kinetic energy is still just a change in energy, is still really just an energy. So therefore, I think the correct answer is that work should also be measured using the unit of the joule, or in other words, measured in joules. So let's check it out. There it is, the joule, which is the same SI unit as energy is measured in.